Section 3.2, example 2, finding the domain of a function. Find the domain of the function f of x is equal to x squared minus 1. So let's kind of look at a couple of different possibilities that we have for functions. So here, this is a parabola. So it kind of has like a U-shaped going off on either end. As we go further and further up, it's going further and further left, just not as fast. And same thing here, as we go further and further up on the right side, we go further and further right. So here, that tells us that all of our x values, we're able to plug any x value in and get some sort of solution for it. Doesn't matter where the x value is. You could put negative a million, positive a million. It's going to be a really big number, but the point is that we are able to input some sort of value here. And now what I didn't notice the book do was actually give you a couple, like the two main places where we are going to have domain errors. So two main places where we are not going to have solutions, or we're not going to have all real numbers. And that's going to be with radicals and rationals. So with square roots, we can't have any negative numbers on the inside. So no negative numbers on the inside. And a really easy way to kind of denote that is to think of a number line. Here in the middle, we have 0. To the left of 0 is going to be all negative numbers. To the right of 0 is going to be all positive numbers. And since we want everything inside of the parentheses to be positive, what we could do is just grab that inside part and say x has to be greater than or equal to 0. X has to be a positive number in order for it to work inside of this square root and have real solutions instead of complex solutions. So from here, what we do is whatever we have in here, we just set it greater than or equal to 0. So that's one domain error. Another domain error is going to be rational functions or fraction functions. So fraction functions, we can't have a 0 as a denominator because we end up with an undefined solution at that point. So here, all we have to do is set it equal to 0, or we could just say that x is not equal to 0. That's going to tell us exactly where we're not allowed to be. So another example of this would be 1 over 2x minus 4. What we would say here is 2x minus 4 cannot be 0. And whatever solution we end up with is the only solution that we're not able to use in this case. So here we would say x cannot equal 2. As long as x does not equal 2, then we're okay here. But at this point of the class, those are the only two places where we're going to have some sort of domain error. We don't want those two to happen. We don't want negatives in the square root, and we don't want zeros in the denominator. So here my question is this a rational function as in fractions, or a radical functions with square roots? It's neither, so it means that we could plug in all real numbers. We could do whatever we want. We could plug in any value in for x. So here the domain is all real numbers. We could either denote it with the all real number sign, or we could denote it with negative infinity up to infinity. So this would be our solution here. And that's it. So two things: radical functions, rational functions are going to have some sort of domain error. Otherwise, the domain is going to be all real numbers. If you have any questions at this moment, please feel free to ask. Otherwise, bye.